This call is now being recorded.
Okay, yesterday, that is in previous lecture, we have studied introduction of animation, then background of animation, then problem statement. Next part is analysis. In analysis, we will study object model, dynamic model, and functional model in detail regarding the animation. So, in object model, we extract objects from the requirement and our knowledge of computer animation and computer graphics. So the terminology from the problem statement is used in object model. Many of the properties we specify for objects come from our intuitive feeling for what an object should look like and how it should behave. So identifying object classes in object model, we start by listing candidate object classes such as we have seen the animation such as cartoon films. There are actor. So for that cartoon films, we require actor, camera, light, scene, cue, render, sequence, and frame. By using these 6 to 7 points, we generate a film. So we will study in detail one by one. So what is actor? Actors are the participants in our animation. Our actors can represent a variety of objects we want to model. So we have tried to determine what properties are important to all actors regardless of the application. In a finite element analysis, an actor could be an element mesh of turbine blade. For a molecular modeling, both atoms and bonds are actors. Then cues. Cues are the actors, cameras and lights. Cues control actors, cameras and lights in the animation. Cues are temporal objects changing the state of the animation with time. Each cue is a series of events. For example, a cue might tell a ball to start rolling across the room or pan a camera across the stage. Anytime dependent action can be affected by a cue. Then renders produce the individual frame in the animation. Rendering is still an active research area in computer graphics. So we must take care not to restrict ourselves to a particular render such as scanline, ray trace, radiosity, or wireframe. The challenges is to characterize the properties of renders to have. Render is an abstract class meant to be overridden by subclasses. So identifying associations and attributes. Here we define association and attributes in the model. Each actor has a model that describes its geometry. Modeling is an active research area and there is no one modeling technique that can be used in all situations. Also, The requirement state that existing modelers have to be support. So model is an open-ended abstract class. So here we define associations and attributes in the model. Actors also have position, orientation, color, and visibility. See any cartoon film, their actors have their position, orientation, their specific colors, and their specific visibility. An actor's orientation is with respect to some origin. We group positional properties such as translate, rotate, and scale under general 3D transform. Actors also have light transmission properties, which we break out as separate objects as new variations may be invented. Then cues. Cues are time sensitive. Each cue has a time interval during which it is active. Usually, the user wants to do something special when an interval is entered and when it is excited. We call actions that should be executed at the start of interval start actions and those that should be executed when the interval expires and end actions. While a queue active, while a queue is active, it executes tick actions at the time resolution of its enclosing scene. So renders needed to know what actors, cameras, and lights are in a given scene so that they can create images. User may not want to render every frame of animation and should be able to specify rendering resolution. The user also must be able to specify a spatial resolution that tells the render how big an image to create and where that images lie in the camera's view space. Graphics people call this spatial resolution the viewpoint of rendering. The background color of rendered image is also a property of renderers. A scene must know what cues and renders are required to create the animation sequence. Like a cue, a scene also has starting and ending action that perform initialization and terminations. So most classes in Oscar animation system have interesting operations. So there are four parts: actors, cues, renders, and scenes. So actors, we certainly will want to translate, rotate, and turn an actor on and off. Cues, we invoke a cue with a tick operation that includes the current time within the scene. The cue performs all its tick actions. Renders, a render operation causes a renders to create one frame of animation. Since a start operation begins a scene's execution, the scene in turn step through its time interval, invoking cues and rendering frames. So identifying inheritance. Scenes and cues both have time intervals during which they can active as well as start, tick and end actions. We group scene and cue under abstract superclass sequencer. Sequences, that is scenes, also have a clock and a time resolution. Cues do not need these attributes as they are driven by scenes. Lights, cameras, and actors all have position, orientation, and graphical transformation operations, which we group under abstract superclass transformable object. So this is a object model for Oscar system. See the figure carefully. See in the figure, there is sequencer. Sequencer have start time and end time. Sequencer also have action in the form of text. So start time, that is start action, tick action and end action. Also a sequencer is divided into two parts, scenes and cue. Scene have current time resolution, start and tick. Cue also only tick. Then scene is connected to the renderer. Renderer have time resolution, background color, frame counter, viewpoint. So these have operations: render, do lights, do actors, do cameras, expose. So again, renderer have two parts: fix and movie by. So fix upload actor, update camera, update actor, update camera, update light, start and frame. In movie, same: update actor, update camera, update light, start and frame. Similarly, there are some transformable objects: position, orientation, scaling, rotate regarding x-axis, rotate regarding y-axis, rotate regarding z-axis. So there is some scales. So these transformable objects works with light, camera, actor. So light have color intensity. There is on off option connected with render. Then camera have properties: focal point, viewpoint, view up, view angle, clipping range. Then it have on off property connected with the render. Similarly, actor have visibility color, then on off connected with the render. Then actor again have two parts, surface property and geometric model. So surface properties such as ambient, diffuse, specular, transparency, geometric model, representation, interpolation. So it have properties such as open, load, close. So geometric models again divided in two parts, fixed model and movie by model. So it have properties geometry and geometry. This is general figure of object model for Oscar system. See the figure carefully. Then dynamic model. See the figure. The same figure divided from object model to dynamic model. This figure have properties. There is start, tick, and end. So start have start time, do start actions. Then whenever start action is done, there is a tick, time plus resolution, do tick actions with respect to queue and renderer. Then after tick, there is time is for tick, time is less than end time. And if time is remaining, then end action is done. So here start action is done with symbol solid ball, and end action is done with this symbol solid ball covered by a circle. The next, this is a state model for scene. Then state model for queue, it have again same start, tick, and end. Start, that is tick, have time is greater than start time. Tick time is greater than start time. Then do start actions. Then do not tick. Then do tick actions. Then tick time is greater than end time. Then do the all actions. Then go to the end action. This is a dynamic model. See figure carefully. The next, the dynamics of animations are specified by scenes, which encapsulates the series of user-defined events. So figure 2 and figure 3, figure 2 and figure 3. See this figure carefully. See this figure. In this figure, camera, camera parameters, camera parameters like transform polygons to viewpoints. Then view polygons. These are the view polygons forwarded towards hidden surface removal, and then forwarded towards visible polygons. So visible polygons starts sends towards surface shading and smoothing, then quantize onto view plane pixels. So shaded polygons quantize into onto view plane pixels, then pixels form a frame. Then actors fit polygons to surface forms polygons. There are two ways to transform polygon viewpoint and ray trace light polygons. Then they are forwarded towards surface shading and smoothing through quantized view plane pixels and forwarded towards frame. Then light parameters, that is ray trace lights polygons, lighted polygons transferred towards surface shading and smoothing to form a frame through quantized view plane pixels. This is the functional model figure. Then system design. So there are four parts: subsystems, concurrency and control, data formats, and trades off. So we will see in detail one by one. First, subsystems. The system architecture groups objects in the system according to steps in the animation process. The orthopomorphic flavor of the model descriptions helps to maintain the correspondence with the animation process. The interactive script generator permits the user to generate scripts using the graphical interface with the script powerful, easy to use interpreter and a library of useful animation operations. We avoid the need to provide a special animation language. Simulators are external analysis programs. Typically, simulators are run separately from the animation process. They provide the physics for animation sequences. Often, a simulator controls the complete animation with Oscar doing little more than positioning a camera and turning on a light. Modelers create the geometrics for actors. They are loosely related to renderers Sin- since some renderers can only process models from the specific modelers. Often the models are made from polygons, but the system must be able to handle other modeling primitives. Frame editor objects do post-production editing, combining frames, and creating special effects like wipes, dissolves, and fades. A frame clerk tracks where each frame came from and where it is stored. It is a data store accessed by other modules. Renderers take actor, camera, and light information to produce a single frame of animation. External renderers run in batch mode, producing their images from command files created by Oxer. Oscar. Other renderers are built within the animation system itself, but all the renderers respond to the same protocol. Recorder objects take finished frame and commit them to film or video. They also respond to a specific recording protocol, converting these messages into device specific control functions. Then second, concurrency and control. Oscar is run as a sequential batch job, so concurrency is not an issue nor an allocation of tasks to processors. Control is implemented procedurally by explicitly sending images to objects within interactive loops, simulating scenes. Then third, scripts are written as sequences of operations in the object-oriented interpreter languages rather than in any special format. The format of frame clerk must be given, but we omit it here. The format of the simulator, modelers, and renderers is specified by the suppliers and is beyond our control. We must accept them as they are. Then fourth, trade-offs. The director and interpretive language must be easy to use and flexible, but they will not consume much run time as most of the execution time is spent in predefined simulators, modelers, and renderers. Thus, we select to make the interpretive language highly symbolic. Operations are encoded as text strings, which are interpreted at runtime using explicit search of the class hierarchy for the methods. Operands are passed using variable length, argument list, and text tools for the flexibility. Setup operations use several levels of indirections for flexibility. We also incorporated several debugging aids. The efficiency of the director is less than 50% but does not matter because the director consumes a small portion of the overall Oscar execution time. Then fifth point is object design. So during object design, we begin to shift our focus from the external requirements to the computer implementation. We extend the object models we derived during the analysis to include associations and the attribute that objects require for internal processing. Most of the design, however, is a simple and direct implementation for the analysis model. So there are four parts: actors, cues, scenes, and renders. We'll see one by one. So first, actors. To retain the state of an actor's position and orientation, we introduce a new class, the matrix. So camera and light also implement much of their behavior with matrix. Each instance of matrix is 4 by 4 transformation matrix that captures geometry of transformable object and provides efficient basis for the implementing motion. Translate, rotate, and scale are simply special cases of the matrix multiplications on 4 by 4 matrix. Successive transformations can be combined by multiplying their respective matrix. Each transformable object delegates its behavior to a matrix object. Then queues. The only external operation on the queue is a tick. The operation is a direct implementation of dynamic model. If clock has just entered the active interval for a queue, execute start actions. If clock is within the active internal interval for a queue, execute tick actions. If the clock has just left the active interval for a queue, execute end actions. This simple algorithm gives the animations system control over any object in the system. Power comes from the ability to use the statement in the language as an action. Later, in some examples, we show how the queue appear to the user. Then next part is scenes. The only external operations of a scene is start, which following steps. First, execute start actions. State current time to start time. As long as current time is less than end time, increment current time by resolution. execute scene tick actions, send tick operation to each queue in the scene, send renders the operation to each render in the scene. Once the scene's current time exceeds its end time, execute scene's end actions. Then next part is renderers. In the renderer class, the render operation is only complicated external operation. Oscar supports many renderers, but all rendering is controlled by uniform protocol. The renderer protocol determines how much data can be rendered based on the renderer's time resolution property. Then it positions the cameras, lights, and actors. The frame is built and an expose operation requested. Finally, the time of render operation is noted and the frame counter incremented. An abstract class called renderer execute the rendering protocol. Specific renderers, the subclasses of this abstract class and must implement any operation not implemented by the abstract class noted as subclass responsibility. The render protocol is work as follows. Render operation. So if the frame counter is not multiple of rendering time resolution, just increment the frame counter and return. If this is the first frame to render, perform the start operation. It is subclass responsibility. Perform cameras operation, perform lights operation, perform actors operation, perform frames operation depends on subclass responsibility. Perform expose operation, update render time, increment frame counter. So there are different operations on cameras, lights, and actors. These operations check their list of objects to see if any have been changed since the last renderer operation. For each changed object, they perform update camera, update light, and update actor with the object name as an argument. So unmodified object use the image from the previous frame. It is necessary to store the current image for It is necessary to store current image for each object as an optimization to avoid recomputation. Next, we describe the subclass responsibility operations for a typical renderer called as Fix Plus. Fix Plus is a graphics standard for three-dimensional display that have a hierarchical display structure. So there is a operations for cameras, light and actors are start, update camera, update light. So if the system is not initialized, open it, create a workstation and set it update mode to default. Then update cameras. Queries are named camera for its viewing parameters and converters the Oscar, Oscar camera parameters into fix plus parameters to form a view operation matrix. It inserts this matrix into a workstation view table. Update light. calculates the light direction vector by asking the named light for its focal point to a position. It is also get the color of light and stores direction and color of light table for the workstation. Then update actor checks to see whether its model has changed since the name the actor has changed. If the model has changed, it applies a load operation to the model. If this actor is not in fix plus actor group, the actor is added to the group and segment is opened. Then update actor queries the status of the actor's positions, color, orientation, and creates the appropriate structure elements. Finally, the segment is closed and posted to the workstation. Frame sets the background for the workstation and tells the workstation to render all segments. These five operations are all the required to add new renderer to the system. Each operation performs one task that does not interact with the other task. The order of the operation is enforced by the abstract renderer class. Then implementation. Oscar is implemented using object-oriented interpreter based on C language. The interpreter implements creation of classes and objects, single inheritance and operations coded as text strings. Its syntax is similar to the Smalltalk with some extensions. The user interface consists of a parser that interprets operations of the form object name message sequence. A message sequence consists of messages with optional arguments. The suffix of the message determines whether a message requires arguments. The following suffixes are used for message semantics. Question mark used for a request or request the value of instance variable. Equal to is used to set instance variable. Colon is used the argument but does not set instance variable. At the rate symbol defines the index. Then plus minus divided by and multiplication, that is terminate arithmetic operations. So messages to one object can be concatenated on statement. A typical statement, suppose actor new a box position 050, rotate x 30, color 101 on exclamatory sign. So actor is a class that responds to new message. Actor is a class that responds to the new message by creating instance itself with a name as a box having position at x-axis, y-axis and z-axis. So classes when the receive message new colon message return the pointer to the new instance that will receive the rest of the message in the statement. And this new actor receives the position is equal to message causing the position instance variable to be set at 0 5 0. So x is equal to 0, y equal to 5, z is equal to 0. The remaining message rotates a box at 30 degree about x-axis and its color is magneta. There is color code 101 for magneta. So here red is equal to 1, 0, green is equal to 0 and blue is equal to 1. RGB. First color is red, then second color is green, third color is blue, and turn on. On colon is known as on exclamatory is known as turn on. The system's knowledge of the problem domain, here computer animation, is kept with -m or with m, the classes, and not in the languages. So here one example is given. A sample animation illustrates the power of animation system and the language. This short animation shows the bouncing ball. Here some code is taken from bouncing ball that start at a rest and moves along the path, simulates gravity. Here we do not use the accurate scientific simulation of gravity, but rather use a sine curve to simulate the motion. First, we make actor for a ball. So we start from 0, 0, 0. So make a red and give the ball called as ball model. So actor new ball position is equal to initially 0, 0, 0. Then color 1 indicates red, others are 0, 0. So ball, this is ball model. So now we need a modeler to describe a physical model of ball. For this example, we use fix plus modeling primitive for sphere. Fix sphere new equal colon ball model with a radius zero point 0.5. So fixed sphere is predefined class that creates fixed plus compatible representation of sphere. So an Oscar camera is similar to physical camera. We give it a position, a focal point, and up direction angle for a lens, that is view angle, and turn it down. So camera new camera 1 position is equal to 10 0 80. So x is equal to 10, y axis is equal to 0, z axis is equal to 80. So focal point, so focal point is equal to 10 0 0. So view up is equal to 0 1 0. View angle is equal to 30 on with x axis direction. So we also need the lights to illuminate the scenes. We place a light at a camera following statements. Light new equal to light 1, position is equal to camera's position. Focal point is earner focal point. So earliest focal point whatever. Then intensity is equal to 8 and which is on. So we have here we used a message sequence with the square brackets. Here message sequence used in square brackets to take result of one message position question mark. So to use an argument for another position is equal to, and this is powerful construct to use the throughout the camera animation, computer animation. Even though the light object does not know about the cameras, the parser provides simple mechanism to s- communicate state information from one object to another object. Then now create a render object that will take the actors, cameras and lights to create one frame of the animation. So fix new equal to renders light is equal to light 1, cameras equal to camera 1, actors is equal to ball. Next, we define the cue that controls the motion of the ball. In this animation, the ball will not bounce once in 6 seconds. Although there are many ways to do this. We use halt or sine curve to simulate the effects of gravity. To make the action more interesting, we add a bit of horizontal motion. The cue will start at time 0 and last for 6 seconds. So this is sample code for cue. New is equal to bounce, start time is equal to 0, end time is equal to 6. So start action. Set new x, that is scalar new x, scalar new y. So tick action, x is equal to 20 divided by 6 into bouncing time. So y is equal to 30 into bounce time of sine curve into 10. So ball position at x, new x and new y and 0 z axis. So scalar is a scalar number class. This message equal to says the scalar instance value, while the message divided by divides the current value by its argument. Likewise, sign exclamatory message changes the scalar's current value into sign of its value. Here, sign exclamatory changes the scalar's current value into sign of its value. To get the value of scalar, we send a question mark message. Here, using simple message passing parser, we have added an arithmetic capability to the animation system. Remember, a queue sends messages to the parser whenever the queue receives the message and time is within the queue's start and end times. So last part of our script defines scene. So scene is equal to new scene 1. So start action is equal to scene 1 starts. Renders is equal to render queues is equal to bounce. And end actions is equal to scene 1 complete. This is the code. So scene starts when it receives start exclamatory message and run until its clock reaches its duration. So scene 1 start exclamatory. An interesting variation of the script places the camera's focal point to ball's position. If follow the bouncing ball effect, and this will keep the ball in the center of the frame. To appreciate these, we should place a few balls of varying size around the floor of the room, which we add as follows. So this is the code: actor new colon room model is equal to room model. Actor new colon is equal ball model is equal to ball model at position 5 to 0 with scale 0.5, 0.5, 0.5. This is for ball 1. Similarly for ball 2, there is model is equal to ball model at position 570 with scale 0.2, 0.2, 0.2. Similarly, for ball 3 model, ball 3 position 350 scale 1.7, 1.7, 1.7. Then render across plus room ball 1, ball 2, ball 3. These follow Q keeps camera's focal point to the ball. So Q ball, Q new follow duration bounce duration. So take actions. A camera focal point is equal to a ball position. Then we add this cue to the scene. Scene 1 cues plus follow time is equal to 0. Then start time. Animations often evolve this way, one cue at a time. We might get more sophisticated and simulate the ball squashing against the floor by changing the Z scale factor. Another cue might pan the camera around the room while the ball bounces. Then last part from this animation, what we have studied in this animation. So Oscar made its first film in December 1984 when it consisted of 25 classes including actors, cameras, lights, cues and renderers. Since its initial implementation, Oscar has gone to contain over 90 classes. Thus, over half the classes share code with other classes. During this project, we made several observations. So, applying object modeling to the animation produces a natural user interface with the terminology that the familiar to expert in the application domain. The abstraction steps, the abstraction step of the design is critical and require the most effort. The object oriented approach partitions a complex system into manageable pieces. The system is less fragile than other we have written. We make changes with the additions without fear of breaking Oscar. So up to this we have studied in this chapter use of programming language and database system, object oriented style, features of object oriented languages, then applications of OMT like object diagram compiler, computer animation. The remaining part is case study of hotel management system and course management system. We will study. So first we will take the hotel management system. The hotel management system is designed to computerize the following functions that are performed by the system. So first is room details functions. So opening a new room, and second is modification of room assigned. Then check in and check out details functions such as admission of new customer, check out of the customer, then room assigning related to the customer's need. So next is statement of customers details. So check in customer details, check out customer, then room details, then total number of customers in the hotel. So depends on individual customer report. So we'll see in detail one by one. So before for reports generating, we require the following functions. First requires customer details, requires requirement of customers, room details, bill details, checking reports, booking details, online booking, checkout details, membership details, and packages available. So we'll see one by one. So what is the objective of hotel management system? So during past several decades, personal function has been transformed from relatively record of keeping of the central and top level management functions. So there are many factors like influenced this transformation: technological advantages, professionalism, and general recognition of human being as most important resources. A computer based management system is designed to handle all the primary information required to calculate monthly statement. Separate database is maintained to handle all the details required to correct statement calculation and generation. So this hotel management system intends to introduce more user friendly in various activities such as record updation, maintenance, and searching. So the searching of record has been made quite simple as the details of the customer can be obtained by simply keying the identification of the customer. Similarly, record maintenance and updation can also be accomplished by using identification of the customer with all the details being automatically generated. These details are also being promptly automated, updated in the master file, thus keeping the record absolutely up to date. The entire information has maintained in the database or files, or whoever wants to retrieve cannot retrieve. Only authorization user can retrieve the necessary information which can be easily accessible from the file. So what is the objective of this project or hotel management system? So there are day-to-day activities like room activities, admission of new customer, assign a room according to customer's demand, checkout of computer and releasing the room, finally compute the bill, etc. Packages available, advance online booking, online cancellation, list of regular customers, email facility, and what is the feedback. So these are objective regarding this hotel management system. So there are some features, that is system connectivity, no data duplication, no paperwork is required, time efficient, cost efficient, automatic data validation, user friendly environment, data security and reliability, fast data insertion and retrieval, easy performance and check. These are the features of this system. Then what are the advantages of that system? The system is useful for the authorities which keeps track of the users registered in a particular state. The authority can add hotel packages, room details, availability of rooms, online booking, etc. The following steps that give the detail the information of need of proposed systems are performance, and during the past several decades there are the records are supposed to be manually handled for all activities. The manual handling of record is time consuming and highly prone to errors. So to improve performance of the hotel management system, the computerized system is to be undertaken. So this system is fully this system is fully computerized and user friendly, even that any member can see the report and status of the company. Then efficiency, control, and security. So the basic need of website is efficiency. Website should be efficient so that whenever a new user submit his her details, the website is updated automatically. A record will be useful for other users instantly. Control. So complete control of the project is under hands of authorized person who has the password to access the project and legal access not supposed to deal with. So All the control under the administrator and other members have the right to just see the records, not change any transaction or entry. And what is the security? Security is the main criteria of this system. Since illegal access may corrupt the database, so the security has given to this system. So, what are the principles regarding this hotel management system? Understand the problem, identify the problem, and record of the origin and the reason, use of multiple use of views of requirements like layers, work to eliminate ambiguity. Then there is entity relations diagram, ER diagrams. So entity relation diagrams, this depicts the relationship between data objects. Attributes of data objects noted in the entity relation diagrams that can be described using the data objects, and description for diagram serves two purposes. First is to provide indication how data are transformed as they move through the system, and second depicts the functions that transform the data flow. So a data object is a representation of almost any composite information that must be understood by the software. By composite information, we mean something that has a number of different properties or attributes. A data object encapsulates data only. There is no reference within a data object to operations that acts on the data. So what are the attributes? Attributes define the properties of the data object that can and take on one of the three object characters: name of the instant data object, describe the instance, make reference to another instance in the table. What is the relationship? So relationship, the data objects are concerned to one connected to one another in a variety of different ways. We can define set of the object relationship pairs that define the relevant relationships. Then there is a cardinality and modality. So what is the cardinality? The data models must capable of representing number of occurrences object in a given relationships. The cardinality may be one to one to many, or many to many. So you know the relation between one to one to many, and many to many. Then what is modality? The modality of relationship is zero if there is no explicit need for the relationship to occur, for the relationship is optional. The modality is one of the occurrence of the relationship. So object relationship pairs can be represented graphically by ER diagrams. A set of primary component is identified by the ER diagram with attribute, relationships, and various types of indicators. So this is the first figure of hotel management system. This is the primary purpose of ER diagram, to represent object and their relationships. So hotel have rooms information, then room, then customer checks in the room. This is simple. So customer checks in the room, In case of cardinality, hotel, room record, and customer. The next context level DFD hotel management system. So this hotel management systems requires customer and customer requires rooms and the rooms related with this hotel. So customer checks out and price device print device. This is hotel management system DFD. Then data flow diagram. So customer arranging a new room. Okay. So there is a file for this room. Display the file, process and get details regarding the room and the customer. Then assigning the room. Then update the details, customer details, update the table and file and assign the room to the customer. This is the details or data flow diagram of check-in customer. Then checkout customer data flow diagram for record modification. So user, so read customer room number, then update the details of the record, then modify details of record, that is update, then file and read the customer room number. Then in case of checkout, scans the customer's room number, display the room, then get details, update, that is customer details, file and check out the room. Then a DFD for listing the customers. So read the room number, then select record from the database from the file, copy the selected record, then generate the total, then print the output and set the record, copy the selected record, then compress, generate the bill, finally final output, that is output unit. Then DFD of generating bill management. So record room number from the file, check for the bills, then generate bill, then take bill from the customer. Okay. Then this DFD for list of all records. What is the functional details? The basic objective of hotel management system is to generate the simplify monthly or day-to-day activities of hotel like room activities, check the number of new customer, check out check-in of new customer, check out of the customer, assigning room according to customer requirement and finally compute the bills, etc. which has to be the performed repeatedly on regular basis to provide efficient, fast, reliable, and user-friendly system. On the basis behind this exercise, so functional details requires the password. So in this module, the website is for the multiple users. If the user enters the password, software checks the validity. If the software is valid, the operation given to change the password, otherwise invalid user or password message display. There is an option for password recovery, logout, login, new users, sign in. The administrator can update changes in the site after login. Then creating new entry, hotel, room, customer, members, etc. This is used to add new employee details, delete entity details, and view details. Then function for new room. This function is used to new room for new customer. So she can assign a separate room. In the screen, the automatic room number is created by opening new room customer. The finally room is assigned to a customer and the room records appended in the data file. Then function check-in customer, then function checkout customer. So this function is used to admit function check-in customer is used to admit customer in the hotel after entering his or her all personal details like name, address, phone, gender, and his assigned room number. Then function checkout customer. This function is used to check the customer details from the database. When the user inputs from the room number, the same room number will be checked in the database. If the room number is matched then in the database, then the customer will check out from the database and transfer to the record of checkouts to the another table of database, so that the hotel management has a record of customer who has checked out to fulfill his legal liabilities. Then function bill generates and display records. Then validation data, searching data, and generating the reports. Okay, and this is up to this we have seen the hotel management system. Then next part we will see the course management system. See the figure carefully. See in this figure, this is entity AR diagram, entity relationship diagram of course management system. So student have student ID, student name, address, contact number. So student pays fees. So on fee, paying name, receipt number, tuition fee, details of dates of receipt. Okay, student adds to the administrator. So admin id, admin name, password. So student enrolls in department, department id, department name. Then department conducts the exams, that is registered number, course, subject name, marks. Similarly, administrator enters to the course id, course name, qualifications, experience. So this course management system we will see in detail. So the purpose of this document to present detailed description of course management system. It will explain the purpose and features of the system. The interfaces of the system will do the constraints under which it must operate, and how the system will react to external stimuli. This document is intended for both stakeholders and developers of a system. What is the scope of this course management system? It domain use to use a large domain. It used for efficient, useful, it service, it university and faculty and schools in university in each course to access, to link e-learning, to show course and useful it service. So there are some definitions and abbreviations such as SHS, that is student homework submission, SIS, a student information system, SGT, actually GGT, that is group grading template, AIS, academic information system, CMS, course management system. So this is a product perspective. The system will operate within university environment. This environment has another system that will interact with this system, and we need interfaces between the system. So this course management system have a database. This course management system have a database, student information system, registration system, academic information. So this product functions, the system will be able to create courses. So this is a student, looks like actor. So student download a course and instructor update the course. Then the system shall be able to automatically create accounts for students and instructors. So this student, this is the instructor. So system shall be capable managing student grades. So student access the grades given by the instructors. Instructor also modify the grades and evaluating students and groups of homework submission online done by the instructors. So the system shall capable of automatically accepting homework submission. So student upload the solution of homework submission. The system can support group management features, especially important for courses with group projects, and this is especially important for large classes. So student can create group, can access group, student drop out from the group and switch the group. Example of WhatsApp group. Admin can create group, access the group, drop out from the group and switch off the group. Similarly, there is another system with provide online quiz. So student answer the online quiz and instructor upload the quiz and upload the answer quiz also. So what are the functional requirements? So creating courses, integration integration with registration form. The system shall periodically upload the latest registers classes to determine the courses that offered in the current semester. The system shall generate course for each class that registered and determine the current set of students that enrolled in the class. The system shall allow course instructor to update course content, grade management, allow grades to be entered online. So system shall allow instructor to enter and modify grades online, allow students to access their grades online. So system shall allow students to log in their account and check their grades at any time. System shall provide statistically information such as average, standard deviation, medians about the student grades. So track and handles regrade requests. So system shall be able to track and handle requests for regrades, and all information about regrades shall be available to the student and the course instructor. And then homework submission, accept the submissions in multiple formats. The system shall accept submission multiple formats including .zip, .c++, .text, .documents, etc. So support for late submissions. The system shall provide information about the late submissions that disallow the submission after certain period time. So this is sequence diagram for course management system. There are three main objects: class, registration system, and course management system. So student register the course, registrating system forwarded towards the course management system. So student register the course, then course management system creates the account and registration is done. So this is the last point or last slide from this chapter 7. So we have completed 6 chapters. Hmm.